Good morning, everyone, and welcome to another April edition of the Southeast Climate Monthly webinar, where we talk about the climate and special topics pertaining to the Southeast region. I'm Sandra Rain, the regional climatologist from the Southeast Regional Climate Center, and I will be giving a climate overview. Our speakers today are Jeff Dober from the Southeast River Forecast Center, who will provide a water resources overview, Pam Knox from the University of Georgia, who will give an agricultural impact update, and our special topics speaker, Victor Gensini from Northern Illinois University, who will talk about tornado climatology and forecasting in the Southeast. We thank them all for joining us. Just a reminder, type your questions and comments into the question box at any time, and they will be answered at the end of the webinar. Also, a recap email of this webinar will be sent out with a YouTube link to this recording. All right, let's talk about the climate. The temperatures for the past month were near average to above average in certain places. In March, Plant City, Florida tied or broke 5 daily maximum temperature records. March 1st, 2nd, 17th, 26th, and 27th. The highest was 94 degrees on March 26th. But when we started with April, a cool down occurred. We actually had an April freeze in the beginning of April on the 2nd and 3rd. Daily minimum temperatures fell below freezing in every state north of Florida, but even the Florida Panhandle felt the chill, with Tallahassee getting down to 34 degrees Fahrenheit. Even with this late season freeze, we've warmed up since then. As average minimum temperatures, you can see they're getting back to near normal. Just a few places still have below average minimum temperatures for the month so far. Precipitation for the past 30 days has been variable. It's been above average in Alabama, but below average in Florida, and near average for Puerto Rico and the U.S. Virgin Islands. We've had 2 severe weather outbreaks for March. The first one occurred on March 17th through 18th, where 25 tornadoes came through Alabama. This is the 6th highest single event including since records began. This included 3 EF2s. The strongest had winds of 115 miles per hour. Fortunately, there were no fatalities with this outbreak in Alabama. The second outbreak occurred on March 25th to 26th. This included an EF4 tornado in Georgia. It had winds of 170 miles per hour. This is the 10th EF4 tornado to occur in Georgia since 1950 and the first one since 2011. Unfortunately, there was a fatality with this storm. From tornadoes, we move on to pollen season. So for the past 2 weeks, I'm sure everybody has noticed a bunch of pollen in the air, but I think so far it's starting to wind down. In Raleigh, the highest pollen count for this season occurred on April 5th with over 2,300 grains per cubic centimeter. In Atlanta, we've gotten over 6,900 grains per cubic centimeter. But again, hopefully it's starting to wind down. However, as we all know, pollen season usually lasts throughout the spring and summer and autumn months. Ragweed pollen will actually peak in the autumn months, so don't put away your tissues yet. As far as La Niña, it continued throughout March, so we're still under a La Niña advisory. However, a transition to ENSO neutral is likely in the next month or so, with an 80% chance of ENSO neutral during May through July. Now, fall 2021 has lower confidence, with a 40 to 50% chance of ENSO neutral or another La Niña, and only a small chance of an El Niño occurring. As we look at the current drought monitor, the western half of the United States is still under extreme drought. This isn't very good for fire season that'll be coming up. And especially for anybody watching air quality in the Southeast, if big fires happen in the West, that might put a damper on our air quality here in the Southeast. However, closer to home, we see that in Alabama, the moderate drought has been reduced due to the rainfall this past month, but in Florida, we do see moderate drought appearing. However, we do think this might be reduced later on. As far as the monthly outlook, it does show that drought development is likely in Florida, which we have seen. However, when we look further ahead into April, the 6 to 10 day outlook from the CPC, which includes April 18th through 22nd, there's a high probability of below average temperatures for most of the southeast. But if you'll notice about precipitation in Florida, there's a probability of above average precipitation for Florida for the rest of the month. And this is also taking into consideration the long-range models, which also show above average precipitation for Florida. So hopefully in the next couple of drought monitors that are released, that drought in Florida will be eliminated. As we get into the 3-month outlook, above average temperatures are likely for the southeast, with above average precipitation for Virginia and North Carolina, and the probability of equal chances of above average or below average precipitation for the rest of the southeast. However, for the rest of this week, we should expect a cold front to move through tomorrow, so that'll probably include some more thunderstorms and some more precipitation, hit or miss. So just to sum up, the temperatures for the past 30 days were near average to slightly above average. We did have a freeze the first weekend in April. Precipitation has been variable, but that's expected for the springtime. We had 2 severe outbreaks in March. We're still under a La Niña advisory. However, a transition to ENSO neutral is imminent. The short-term drought in Florida should be reduced. And for the next 3 months, we will likely warm up with Virginia and North Carolina likely to be wet. So now I will turn it over to Jeff with the water resources overview.
Okay, thank you, Sandra. And we'll start off here showing the current 28-day average stream flows. And as you can see, a little bit of a change. We still see above normal stream flows to near normal across most of the Carolinas, especially the headwaters. We're seeing high stream flow levels. But we also see a transition there across Alabama, especially in the Alabama rivers, the Alabama River watershed, as well as the Tombigbee, all showing above normal stream flows in their headwaters right now. But Georgia and Florida, they're for the most part at normal stream flow levels. As far as the region as a whole, you can see the graph there on the right. The region as a whole, we're running about normal, but as you can see, as we go into the late springtime period, stream flows do drop off during this time of year as we head into the summer months. And this is a factor of slightly decreased rainfall during the month of April, as well as temperatures warming up and evapotranspiration rates starting to pick up here. So we'll go to the next slide. And we'll break it down by states here. And you can see, again, Alabama has been the wetter part of the region. And so stream flows have responded. And as you can see, on average for the state, we're in the above normal range. But as far as Georgia and Florida, near normal. Florida on the cusp of going into below normal. Next slide. As we go into the Carolinas, South Carolina, North Carolina, and Virginia, all running right there just below or right at the above normal to normal threshold as they continue to see what they have been regular rainfall events passing through the region. But as I pointed out, stream flows on average do go down during the next couple of months here. Going to the next slide. And I'll show you here's the current river conditions as far as flooding across the region. And most of our flooding that we had in the lower reaches of some of the Carolina rivers is waning now. We do have some minor flooding still on the lower Savannah, as well as on the lower Santee at Jamestown, South Carolina. But for the most part, flooding beginning to continue to decrease in the Carolinas. But now we've seen a pickup here across parts of Alabama and northeastern Mississippi and the Tombigbee River watershed, as well as the Florida Panhandle. A lot of rivers at bank full with recent rainfall, recent thunderstorms from last week. Next slide. And as we always do, give you an idea where we're at as far as river flood climatology. And we are past pretty much the peak primary recharge period. We're in week 15 here. And as I pointed out, over the next several weeks, typically the chances for flooding decrease dramatically. As we've seen the green wave, as Pam calls, we call it the green up across the southeast. Evapotranspiration rates pick up as temperatures warm, and also as April sees actually some decrease in rainfall across the region. So in a couple of weeks here, we'll actually be at our annual mins. Next slide. So again, we've showed this slide before. The typical periods for high stream flows in the southeast are January through April. So with the exception of the Florida Peninsula, where August through October during the tropical season is where we see the highest stream flows. Next slide. And I wanted to point out too, here is the moderate to strong La Nina stream flow analogs for the month of April. And I wanted to show how this somewhat matches up with the current stream flows. And now, again, this goes back to what I think David Zierden has brought up in the past as well, is that even though La Nina, moderate to strong La Ninas generally tend to produce below normal stream flows across most of the southeast, especially the Florida Peninsula, this is not always the case. And this sort of pie chart shows that it's not 100%, of course. But it does mimic it pretty well for April, as we can see that the favored area for above normal stream flows is actually across parts of Alabama, the Alabama River watersheds. As you can see there, the green slice of pie on the left map. And of course, you compare that against the current stream flows there on the right map. Next slide. So this is what we're looking at as far as the late spring flood outlook. Now we're almost into the month of June for the next 3 months. And really, we're looking at probably more typical flooding, which is really the flooding chances. Usually, as we get into May and June, river flooding becomes fairly isolated and minimal relative to the year. But that doesn't mean that we're not going to have any river flooding. So that for the most part, we're going to see typical flooding, which is minimal river flood events over the next 3 months. So in summary, stream flows remain above normal across many of the headwater reaches of the large rivers, with near normal elsewhere. And this drier weather and warmer temperatures, that'll decrease stream flows across the region in the late spring. And then our late spring flood outlook, for the most part, calls for typical late springtime river flooding, which is fairly minimal. So we're seeing many of the reservoirs move to their summer pools. That'll help accommodate some of the higher flows and some of these stream flows, again, as well as the increase in temperatures and the green wave. That'll cut off our runoff. And so we're heading into a period now where flooding becomes less likely. And that's all I had. So I will pass it on to Pam for the agricultural impacts.
All right, well, thanks, Jeff, and good morning, everybody. It's good to talk to you again. Let's jump right into the slides here. The overall conditions for agriculture, Sandra's already set us up pretty well. I'm not going to spend a lot of time on this. It's been a little warmer than average for the last month, and it's been a real wet or dry across the southeast, with Alabama getting a lot of the wet conditions and a lot of the rest of the region, especially southeastern Georgia and coastal South Carolina being quite dry. So the impacts have varied depending on which part of the region you are. And so we'll look at some of those impacts in just a minute. Let's go on. just a quick look at the lawn and garden moisture index from the University of Alabama at Huntsville. You can see it's been quite dry in a lot of that eastern Georgia, South Carolina region. So they really need the rain, but it's likely we're going to see some rain. So I don't think that's a huge concern. Some farmers are actually appreciating the dry conditions because it allows them to get more field work done. Potential flash drought development. There's a few little spots there, but I don't think there's anything that's really showing that it's going to worry. And this particular map is pretty old, so maybe that with the rain we had this past weekend, some of those spots might even have gone away. Let's go on. This is a temperature timeline from North Carolina. They have a new data portal called Cardinal, and I had to take the chance to use one of their stations to show this. This shows the daily or the hourly temperature and the hourly dew point at one of their stations in the Piedmont. And you can see it starts sort of in mid-March, just a little after our last webinar, and goes through yesterday. And you can see during that entire time period, the temperature has been above freezing, with the exception of going down to real close to freezing on March 20. But so it's been a long time with no frost. And so people have been very eager to get out in the fields and get things out. But we did have the late frost on April 2, and that was an advective freeze. The wind blew it in, but the winds were pretty high up, which means it was a little tough to do frost protection using irrigation, just because if the wind's over about 5 miles an hour, spray goes everywhere and it doesn't really protect the plants that well. And then the second night it calmed out, and so the temperatures dropped a little bit lower, especially in areas that are already prone to frost. And so there was some more damage from that as well. And since that time, see lots of sunshine, pretty typical daily temperature variation. And then with the weekend, we had the storms come through and things have dropped off and dried out quite a bit since then. We go on to the next slide. Some of the impacts of those things are, we had that warm spell. Of course, February was quite cold. So the warm spell, everything was ready to go. A lot of plants bloomed. That really contributed to the pollen loads that Sandra was talking about earlier. So we had a lot of things blooming all at once. Fruit trees and crops were all coming out of dormancy, and that was the green wave that I've mentioned before. The cold spell that accompanied the frost did slow down the planting of corn and some other crops, because if the soils are too cool, you don't really want to put seed in it because it just sits there and it doesn't do anything. And so people have been waiting till the soil warms up a bit, and that has really happened a lot in the last week. We'll probably see another cool spell coming up here in the next week, and that may slow things down a bit again. The dry conditions in those areas that were dry did allow people to get field work done, but really impacted the ability of pastures to green up, and also impacted some small grains like wheat. And so that's been a concern. The areas that are wet, they did have some problems with drowned pastures and wheat that was in low-lying areas that's getting drowned out, no oxygen getting to the roots. And there's a lot of home gardeners that I see on Facebook who planted early because they love that warm weather and got hit by the frost a little bit. Most commercial growers did not really, weren't quite so eager to do that. And I think they kept in mind there might be a late frost. We go on to the next slide. This is a count of the number of days that got to 30 degrees or below. If it gets just down to 32, it's probably not going to cause a lot of damage. 32 or 30 degrees is a little bit more in the realm of something that can cause serious impacts. You can see a lot of the region had both days, April 2 and April 3, that got down to 30 or below. And so those are areas where we look for the biggest concerns with frost damage. There were some other areas down in southwest Georgia that got down to 32 or even 31, but didn't quite get down to the 30 level that was counted for. And that was, you know, fortunate for them because there's blueberries down there that are opening up for self-picking this weekend. So they're definitely at a very vulnerable stage. So some of the growers did think that those higher dew points that have occurred in some places help keep the temperatures from falling down too far, and that was a real help. I know that they were doing some irrigation for frost protection in some of the areas. A lot of the strawberries in the coastal plains were covered up, and they had very little loss from the strawberries because of those covers. We go on. Here's some of the damage that was reported to me. Peaches have been blooming widely across the area. The worst damage seemed to occur just sort of outside of the Georgia mountains because the higher elevations had not bloomed as much yet. Had heard a few places that lost well over 50% of their crop. They'll probably still get some peaches out of it, but not nearly as many as they'd hoped. There were a few growers of vegetables like watermelon that lost almost their entire seedling crop because they planted it a couple weeks earlier. But most places didn't get too badly hit by it. Strawberries, as I mentioned, were mostly covered, so they only lost a couple percent, and that shouldn't really be an issue. Corn was damaged. You can see a picture there of the corn on the bottom. A lot of the leaves died out along the edges, but the growing point was still underground where it was pretty warm. So the corn will slow down a little bit in development, but it will grow out of it, no problem. And the blueberry losses in mid-Georgia were about 30% from my reporters there. But they did note that usually blueberry growers have to thin their bushes so they get bigger berries, and they hadn't done that yet. So the total loss will probably be less because the frost was kind of a natural thinning mechanism for that. We go on. This is the rainfall map that's expected in the next week. It's from one model, so you always got to keep that in mind. But it does show that the wettest conditions are likely to be along the front. There, it's stretching across North Florida, and then on into South Georgia and South Alabama as well. Other areas will be hit lighter. Doesn't look like it's going to be too bad. And if you look at the forecast for temperature, it looks like it is going to get colder, but the only indication of frost that I could really find was up in the mountains, where this time of year it's not that unexpected. We go on. This is the last time this spring you'll see the frost maps here. We are now in the dark purple week. So you can see for the mountains of western North Carolina, this is the average date of a last frost for them. So it wouldn't be that surprising if they still got some frost. For most of the rest of the region, maybe 1 in 10 years we get a frost later than this, but I don't really see any indications of that coming up. So I think we may have seen our last frost for most parts of the region this spring, and we won't have to worry about that again until fall. Let's go on. Some of the threats to the agriculture that are coming up. The places that did have frost damage introduces injury to the plants, and that makes them more susceptible to diseases. Insect pressure also goes up, and so that's something that they have to scout in their fields very carefully. The cool conditions are going to slow down crop development a little bit, but I don't think it's going to be cold enough to worry about frost in most places, except in the mountains and those frost pockets that we have scattered around. As Sandra mentioned, the La Nina is waning, but with neutral conditions, it does mean another active Atlantic tropical season, and we do expect that. We don't know where those storms are going to go. Last year, we got a lot of rain from those. They could all go to Texas this year, or they could go up the East Coast. So that's something we'll have to watch, but it's certainly something to keep in mind and prepare for, because you just don't know when it's going to happen. And then finally, the flash drought likelihood right now seems to be fairly low, except for maybe southern Florida, but it's something you need to watch, because when plants are growing, they can go into drought conditions very quickly if we do have another big high pressure that stops over us and shuts down the precipitation. So if that happens, please report your impact so the drought monitor can be right on top of that. Go on. And just a quick summary. The variable rain conditions, as you expect, have hurt some farmers and helped others. The warm spell really moved things along as far as crop development, but the cooler conditions have put a little bit of a break on that, not too much. The early April frost did cause some damage to blueberries, peaches, vegetables, and other crops, but it certainly was not as bad as it could have been, all things considered. And so that's really good. Obviously, some people got hit harder by others than that. And then finally, the water use by actively growing plants Now that the green wave has passed, this means that evapotranspiration is going to increase the use of soil moisture. So dry spells are going to have a greater effect. And that's why it's important to keep an eye on your local conditions and report them so that we know that it's happening. Nothing like having eyes on the ground. And that's all I've got. And I'm going to pass it on to our special guest speaker, Victor.
Thank you so much, Pam. Thank you everyone for tuning in. Wow, fantastic overview of southeastern climate. That's great. I couldn't help but think, looking at some of those maps, especially the precipitation anomalies across Alabama and portions of Mississippi, and even as you get into northern Georgia, the sort of 3 significant days this year for severe storms that helped contribute to those above average precipitation anomalies, mainly March 17th, March 25th, both of which were, I believe, were covered earlier. And then just as recently as March 9th with baseball size hail in Orange Beach, Alabama, which I think may not be the record setting hailstone for Alabama, but will certainly be, I believe, probably when it's all said and done, at least in the top 5 when it comes to largest hailstones recorded. And this was right up along the Gulf of Mexico, which is usually, very anomalous when it comes to large hail locations. So again, thanks everyone. My name is Victor Gensini. I'm a professor up at Northern Illinois University on the west side of Chicago. A lot of my research does focus on severe weather climatology. And so I want to talk to you a little bit about that today, specifically focusing on the southeastern United States, and not only just some climatological work we've done that is very important for the Southeast, but also we can take maybe a quick look at what to expect for the rest of the year, given the La Niña conditions in place, usually favoring severe weather outbreaks in the southeastern United States. So let's go ahead and move forward. I have a couple of newspaper clippings here, and you can run through these, but I'm sure you've seen some of these in the headlines of severe weather sort of shifting into the southeastern United States. This was some research that Dr. Harold Brooks from the National Severe Storms Lab and I published back in 2018. And of course, the media headlines, as with any climate story, I'm sure you guys are all well aware, stay away from the comments, right? As if I'm somehow getting paid millions of dollars to report this type of research. The issue here is that, we wanted to basically assess what severe weather was doing at the local scale. So when you look broadly across the United States, what you see is actually the number of tornadoes we get every year, especially strong tornadoes, is relatively constant. The upward trend that you see if you look at EF0s alone is actually primarily due to increases in reporting, increases in population, right? Doppler radar detection, storm chasers, etc. But what's not staying the same is where these tornadoes are happening. So of course, the media runs with this shift in Tornado Alley, which you'll see today is not true. It's merely spatial trends. But this is really what you see. The modern era of tornado reporting really started in the middle 1950s. And if you look at specifically, let's just look at the orange line there, the middle red, darker sort of burnt orange color. Those are the number of EF1s since, and again, your good record starts in the middle 1950s. You can see there's really no trend across the United States. And if you look at the Southeast in particular, you'll see that trend actually goes up. But this is for the entire United States. The black line, which is another line I want you to draw your attention to, is what we call the Tornado Environment Index. So you can sort of think of that black line as how favorable are the conditions across the United States for producing tornadoes. In other words, when do you kind of have tornado watch situations like we had on March 25th and March 17th across the Southeast? When is the atmosphere supportive of tornadoes? And you can see that too, when you look at that through time, has been relatively constant across the entire United States. So we don't see any significant trends on the CONUS scale, but when we start, this is the motivation for this work. What happens if you look at more of a regional scale? Have we seen changes in, say, the number of tornado counts across the Southeast versus the traditional areas of say, the Great Plains and the Midwest? Next slide. Yeah, so this is just kind of highlighting this dichotomous period of what I'm going to show you. Most of the research here that we've looked at starts at about 1980, and there's a very specific reason for that. We use reanalysis data. Prior to 1979, we don't have significant satellite observations. You do have radiosondes, but they're limited across the US. And so we're kind of stuck with this temporal period that's relatively short from a climatic perspective, but at least allows us to assess trends, say, within a 40 or so year period. So a lot of the work that I'm going to show you coming up here is really focused on this period 1980 to present. Next. So what are we going to look at? I want to show you the trends in what are called the significant tornado parameter. We'll certainly look at tornado counts as well, but the ingredient that we really want to look for from this reanalysis product is called STP. And really STP is just a formula for trying to figure out when in the atmosphere is supportive of tornado events. So in the bottom left, the color filled shaded there is essentially the significant tornado parameter value in the afternoon of April 27th, 2011. You can see the very high values across portions of Mississippi, Alabama, and even as far north into Tennessee and Kentucky. And then the tornado reports, plus or minus 3 hours, are shown in the black dots there as well. Another event over on the right, sort of a more classic Great Plains event. And you can see, of course, doesn't just because the environment is favorable doesn't mean you're going to get tornadoes. But from a climatological perspective, you can use STP as sort of a measuring stick to see how active particular seasons or days or years are with respect to tornado activity. Next slide. So how does STP compare with actual tornado counts? Probably no surprise, they're fairly well correlated when you start at this 1979-1980 period. This was going up through, I believe our last data point here was 2017. I've filled this in since, and the correlation between these time series is about 0.72. So in other words, the blue line showing you the annual tornado counts, the red line showing you this accumulated, you could think of it as sort of accumulated precipitation, but instead of precipitation, we're just measuring the accumulated STP across the country. And so, yeah, years when you're active, you get some bursts there in tornado counts, and it doesn't always mean that high years are going to have high tornado counts, but it's from a climatological perspective, we think the STP is a really good measuring stick for assessing annual tornadoes, because there are a lot of issues with tornadoes, right? Is somebody there to report them? And when you look at things through time, especially tornado accounts, they're getting reported now more often than they were in, say, the early 1980s. Next slide. So when you break it down by month, and one of the really interesting stuff is when you break it down by season and by region. This is still for the United States, but on average, these are looking at the standardized anomalies on the x-axis of the STP parameter, and then the monthly tornado reports on the y-axis. And so you just see this nice kind of one-to-one line for many seasons, basically saying if you are above average across the country with STP, you are very likely to be above average in terms of your monthly tornado reports. And the associated R-squared values and p-values are shown there in the upper left. But the takeaway is that STP is a pretty good predictor, but even better in the cool season and transition seasons of fall and spring. Not so great when you get to the summer, right? You can see the August there, the R-squared drops to 0.09, and that's probably not too surprising for many of you who are familiar with tornado forecasting. As you get into the boreal warm season, it becomes really hard to predict when and where tornadoes will occur because of the mesoscale nature to the thunderstorm complexes that are producing these tornadoes. Next slide. All right, this is the fun stuff. So this is basically looking at a grid point representation of the slope of STP over a 40-year period from 79 to 17. In other words, if you're sitting in Nashville, Tennessee, your trend over the last 40 years in accumulated STP has been down, and it's been down significantly. The hatching area there is the 95% confidence interval of Kendall's Tau test using Thyssen slope. Across the Great Plains, you've seen this decrease in the annual accumulated STP values, indicating there that at least over the course of time, the tornado environments there have trended less favorable than they have in, say, a place like Jackson, Mississippi, or Birmingham, Alabama, or even in my area here of northern and north central Illinois. And of course, this shift, a lot of people like to look at this map and say, well, this is a shift, right? This is a change, and we're moving Tornado Alley, and that is not the case. Central Plains still see a majority of the tornadoes every year. It's just that they're happening there less frequently in a place like Dallas-Fort Worth than they were 40 years ago. So it's just looking at the slope at the grid point with respect to time. Of course, really, once you get east of, say, the 100th meridian, that's a pretty significant upward trend really in a good chunk of the Mid-South and Midwest, but really as far east as the Carolinas, the Piedmont, and you can see the upward trend of the Northeast, although it's not significant, still show an increasing trend in the annual accumulated significant tornado parameter over that period. Next slide. So that's just environment, right? What happens when you look at reports? This is excluding EF zeros. If you throw EF zeros here, the signal just gets even stronger across the Mid-South. So let's just look at tornadoes that cause, some degree of damage that's notable. This is the trend in EF1s from 79 to 17. Again, see this picture here of decreasing trend of EF1s across north central Texas, a pretty significant decrease in northeast Colorado, which for a long time in the tornado climate community was sort of ground zero for the production of landspouts and weaker tornadoes. Decrease also as you get further to the east, sort of on the northward periphery of the colloquial tornado alley, which is a term that I sort of don't use anymore, and I can talk a little bit more about that later. But it's this increasing trend in the Mid-South that has a lot of us researchers pretty concerned, not necessarily because of the trend itself, but because of the impacts that it's been causing, significant tornado injuries, casualties, fatalities, et cetera, because of this region being very vulnerable to tornado fatalities, which I'll elaborate on in a little bit. Next slide. So I show this work and I get a lot of FAQ, right? So we're going to start sort of the FAQ section. What happens if you break it down seasonally? When is this increase happening? Well, it's happening in the cool season. We're sort of starting severe weather season a little bit sooner across the Mid-South. You can see the increases there in the Gulf Coast states in Dec, Jan, Feb in the upper left. Of course, when you get into the core of tornado season, March, April, May, big increases there shown across the Mid-South and decreasing trends in the Southern Plains. June, July, August, this is sort of fitting in with what our climate models would suggest, a drying out of the Southern and Central Plains, sort of a significant sensible heat feedback here. We get less precipitation, more sensible heating, more drying out of the plains, and really an establishment of the subtropical area of high pressure and really moving severe weather away from an otherwise very favorable regions in the Central and Southern Plains. So seasonally, you definitely see that shift in all seasons. But for your severe weather season in the South, which really accompanies all of these months, but is primarily in March and April, you can see that robust increase across portions of the Mid-South there. Next slide. So I get a lot of questions. Let's look at the first one. What if you start in 1974? The April 3rd, 1974 super outbreak. So let's remove April 3rd out. The trend doesn't change. This is Thyssen slopes. This is a very important slope calculation because it really is insensitive to these outlier years that can influence your results, like 1974 or let's say 2011, which is the next one. So let's go to the next slide here. What happens if you this is going to look at the full record first, sorry. What if you start in 1955? This is the modern era of tornado reporting. So let's look at the slope over that entire period, all EF1s. Again, CONUS wide, no change at all, but spatially increases across Mississippi, Alabama, North Georgia, and really extending all the way up into the Ohio Valley, while you see traditional areas here of the Great Plains actually showing a downward trend in many regions. Now the numbers here, you might be looking at this going, what are the units? This is really looking at an F1 per decade. So you're not looking at significant changes, but on the course of let's say a state, the analogy that I like to use here is, the difference between a 200 and a 300 hitter in baseball or softball is about 1 hit per week over the course of the Major League Baseball season. So 1 hit per week between a 200 and a 300 hitter. Now, if you are a very astute baseball or softball observer, it would be very hard for you watching games to see the difference between a hitter at the weekly scale, right, of the 200 and 300 week. But when you aggregate that over the entire course of the season, we would all agree that the 300 hitter is a better hitter than the 200 hitter. And that's exactly what you're seeing here. These trends are not significant, over the course of a year or maybe 2 years or 3 years. When you start to aggregate them over the entire temporal sample, these changes actually are pretty significant and mean a lot for things like emergency managers, local National Weather Service offices, or just people that are generally impacted by, or generally interested in climate impacts on a regional scale. Next slide. You can look at differences in strength of tornadoes, EF0s, EF1s. If you go to EF2s, your sample size starts getting really small, but you can still see some significant decreases, especially in north central Texas and the periphery of the sort of tornado corridor that we generally talk about to the north. But you do still see some significant increases in portions of the Nashville County warning area and the Paducah, Kentucky County warning area and the National Weather Service. And they are very interested in those trends, obviously, because these EF2 or greater tornadoes are the ones that generally cause, damage to lives and property. Next slide. So why does all this matter? I have a couple summary slides here, and then we're going to be finished. But I think if you've been watching at least the tornado, let's say, I don't know how I want to frame this discussion, but recently there have been some news stories that have quoted myself and others discussing the term tornado alley and how it is sort of doing a disservice, especially to the residents of the southeastern United States. And of course, there's another slang term, Dixie Alley, that has entered not only into the research community, but into the media over the last 15 years that, of course, has significant connotation associated with it, negative connotation associated with it. But this idea that where people are being injured and killed from tornadoes is not where tornadoes are generally thought to occur. In other words, most residents of the US, when they think of tornadoes, they think of Dorothy, they think of Wizard of Oz, they think of Kansas, Oklahoma, and Texas. And certainly if you look at the bottom left, right, picture there, tornadoes 1950 to 2004, you can see why people think of Kansas, Oklahoma, Texas, Nebraska, and portions of Iowa as quote unquote tornado alley. This is, again, I think a media derived term. But the issue here is if you look at the bottom right image, which is significant tornadoes, F2 or greater, it's not the same distribution. You can see the eastward extent of significant tornadoes does include that, that second most significant contour does include portions of Mississippi, Alabama, Tennessee, and really even portions of Illinois and Indiana. And you can even see the extension further to the east of that. So this notion of an alley, which when I think of an alley, I think of a bowling alley. There's lanes, where these tornadoes are occurring. That is not a great term for a majority of people that think already, tornadoes are rare. And if you've never seen one, you probably only are, your mental conceptual model of what a tornado is probably Wizard of Oz or Twister or some Hollywood movie. That becomes a big challenge, especially with tornadoes in the southeast that are already very hard to see. And we'll talk about some of that vulnerability in just a second. But the top picture is the only picture that matters, right? When you start talking about societal impacts, look at where people are being killed from tornadoes. It's not in the Great Plains by a lion's share. Once you get west of the 100th meridian, it's really unlikely to see a tornado fatality, actually. Where is tornado fatality alley? That's actually, Memphis, right? Northern Alabama, northern Mississippi. This is not what we think of when we think of your traditional tornado alley. And so this creates, I think, a disservice to people. So we really need to move away from the term tornado alley and let people educate them to let them understand that tornadoes happen in all 50 states, including Alaska and Hawaii. And it doesn't matter what the calendar says. If it's January, December, June, July, it doesn't matter. If the ingredients are present, tornadoes can form, and we need to educate people. Of course, there are tornado seasons, yes, just like there are hurricane seasons. But as we've been seeing lately, even with hurricane seasons, that's not the only season, quote unquote, where these events can happen. Next slide. So just very quickly here with the last couple minutes, 2 or 3 minutes here, why does the Mid-South have a disproportionate number of casualties? So looking at injuries and fatalities. Next slide. It's probably no surprise to many of you that there are a number of factors that really drive the impacts of the significantly greater impacts of tornadoes in the Southeast. This is some research from Dr. Walker Ashley, my colleague here at NIU, who's looked at the percentage by state of tornadoes that happen really between sunrise between sunset and sunrise. So really looking at nighttime tornado fatalities. And what you see is, your southeastern climate region there's really very few states that have percentages of their tornadoes where, less than half are after dark. And of course, tornadoes in the evening hours, in the overnight hours, are much more dangerous because of people sleeping, right? And if you don't have a way to get the warning, this becomes a really, really significant problem. Whereas you get out to the Great Plains and maybe 1 out of every 10, 2 out of every 10 tornadoes happen after dark. This is a perennial problem. We've seen this already this year on the 17th and the 25th, where we had tornadoes occurring after sunset. You get these strong synoptic systems and favorable environments that are advective in nature and keep the favorable ingredients in place in the overnight hours, which causes, unfortunately, a disproportionate share of fatalities, but also fatalities that are occurring between sunset and sunrise. Next slide. So nighttime tornadoes are a problem. What else is a problem? You can click again to advance. I just want to highlight here the southeastern United States. And of course, many of you who live in the southeast, I lived in Athens for a while. In fact, I know Pam Knoxwell and her husband John at the UGA, the Georgia pines, right? You get these tall pine trees in the southeast that make seeing tornadoes, if you're outside of the Delta regions, very, very difficult, right? I would never send anybody storm chasing to the southeastern United States. It's just very, very difficult to spot storms unless you have some sort of elevated building or plateau that you can get up on top of to see these storms coming in. The forest cover also plays a significant role in just reducing situational awareness, especially a couple of trees with night. That is even a bigger recipe for tornado casualties. Next slide. But perhaps the most important one is the number of mobile homes in the southeast. You can see here, this is a climatology from 85 to 2005. Majority of fatalities are happening in mobile homes. Something now, I think if you do the latest numbers to the last 10 years, it's something like 55, 56% of people that are killed from tornadoes are happening in weak frame housing stock, so mobile structures. Next slide. And then of course, if you look at that distribution spatially and press again, click one more time to kind of highlight there in the southeastern United States, that same region, right? We have some counties, as you guys are well aware, in the southeastern United States that are 30+% of mobile home by county. And it's not that they're just concentrated in mobile home parks, if you will, like they are in the Great Plains or in the Midwest, for example, up in northern Illinois. We have mobile home parks as well, but they're very concentrated structures. Across the southeast, they're more scattered across the landscape, essentially creating more targets for tornadoes to hit, unfortunately. And then, of course, if you take this one step further on the next slide, where are people dying in mobile homes? And you again see this sort of spattering across the country, but most of these, if you were to do a cluster analysis here, Western Tennessee would certainly show up, North Central Alabama, shows up as these significant mobile home fatalities, significant number of mobile home fatalities across the southeast. This is multifaceted, of course. If you go to the next slide, just to reiterate, I mean, there are a host of issues. You can't just point to one. But one of the things that I've been trying to tell people in the southeastern United States is that if you live in a mobile home, you should not be waiting until the tornado warning is issued, right? You should be taking action at the watch stage. In other words, if a tornado watch is issued and conditions are favorable, if you live in a mobile home, that's probably the time that you need to take to execute your safety plan. You can't wait for a tornado warning in a mobile home situation, because taking shelter in a mobile home is not going to prevent you from being a casualty to the tornado. We didn't talk a lot about this, but storms, there's some research that shows that once you get east of the Mississippi, storms tend to move a little bit faster. And this is primarily because they're more likely to happen in February, March, and April when the jet stream is a little bit stronger. So storms tend to move a little bit faster. I think one of the major misconceptions is that, tornadoes just don't happen. Well, we look at climatologies, look at significant events as far back as the late 1800s in the Southeast. I mean, the Southeast still gets strong and violent tornadoes. They are not immune. And this perception that these strong tornadoes are only happening in Oklahoma needs to be put to rest. Higher population density, that's kind of a no-brainer, but something that sometimes is lost on this. As you get east of the Mississippi, of course, you just have more targets to hit, more assets to hit. The one thing that I like to look at a little bit, I'm very interested in, is number 8, the lack of a focused tornado season. And this is the idea of complacency. Let's take a place like Birmingham, for example, where you could there's a low risk of tornadoes that happen in Birmingham really all year long, outside of maybe 1 or 2 months. There is a chance or a probability for tornadoes if you look at climatology there. If you look at a place like Amarillo, Texas, or Oklahoma City, they sort of get nothing, 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 and then all of a sudden tornado watch, tornado watch, tornado watch, tornado watch, and then it's the end of the season. There's like literally a 3 or 4 week period in the southeastern United States, or in the Central Plains, where tornado season happens and then it shuts down, right? So this broad tornado season, sometimes where you get nothing, tornado watch, nothing, tornado watch, can lead to kind of complacency with residents. Of course, a whole other host of things that we don't have time to talk about now, and I've already taken up my time here, but I wanted to present to you sort of just a little bit of the challenges here, this moving goalpost, if you will, of climatology that is putting a lot more people at risk, or at least higher probabilities of seeing tornadoes in the last 40 years. And of course, just some of the things that National Weather Service offices across the Mid-South, Southeast, and Northeast, and portions of the Midwest struggle with every one of these outbreaks that we have. And of course, with the La Nina conditions in place, the temperature outlook over the next 2 to 3 weeks was already shown. We do expect below average conditions for tornadoes here over the next 2 weeks, but there is some signal from the Madden-Julian oscillation that we will be back to a very active period by the time early May starts to kick in. And of course, these are the types of events, right, that we want to be watching for. The March 17th of this year, the March 25th, the April 9th. These are the ones, that forecasters always kind of tend to keep close eye on and make sure that we're getting the warning out to as many people as possible ahead of time. So with that, thank you all so much for attending this webinar, and I hope some of my information was helpful, and I will probably turn it back over to, I think, Meredith at this point.
Excellent. Thank you, Victor. That was an outstanding presentation. We have a couple of comments and questions. If anyone else has, please enter them now into the question box about anything you heard today or about climate writ large in the Southeast. We have a few experts online to help answer some of those questions, including some of our state climatologists. Just a reminder that a recap email will be sent out, if not today, then tomorrow, with key takeaways and a recording. Please feel free to share that. You can also access these on drought.gov. My name is Meredith Muth. I am one of the co-organizers of this webinar series, which is co-organized by NOAA's National Weather Service, the Southeast Regional Climate Center, and the National Integrated Drought Information System. Our next webinar will provide a special presentation by one of the authors of the U.S. Drought Monitor. This is a map we show every month. In fact, several of our panelists often show the map. So we want to give you a little bit of a description on how it's made and help you understand these types of data and tools better. Also, at the end of this webinar, a quick survey will come up. If you haven't answered it before, please do so. And any suggestions on future topics you would like to learn more about in the Southeast. Okay, Victor, most of these questions are for you. First
I see one in the chat. I'm not sure. Victor Murphy has a question. I'm not sure if there are others. I can see one question in the chat.
Gotcha, Victor. I'm going to read them out. We can go ahead and do Victor Murphy's question first, and then I'll read you the other ones.
Sure.
I know that we only have 5 minutes left in the hour, but if you're able to stay a few minutes extra, that would be great. Feel free to stay with us.
I will answer as fast as possible.
Great. So first question from Victor Murphy is, what do you attribute the decrease in tornado frequency in Texas and Oklahoma to?
Great question. We've done some research and it looks like it's convective inhibition. So SIN, in other words, this lid that is often present in the convective environment that inhibits thunderstorm formation. And so basically warmer temperatures up at about 3 kilometers off the surface of the earth, about 700 millibars or so. Temperatures have been warming over the desert Southwest. In fact, we have a significant drought, as you guys showed in the drought monitor, in place over the southwestern United States. We're curious if the elevated mixed layer, this layer of SIN, is going to be stronger this year, which will actually continue to move the severe weather further to the east. So far as we can tell, it's SIN. Is that attributable to climate change? I think the answer is absolutely possible. We need some more attribution work to look at that, but this is certainly something that is consistent with our climate models in terms of a drying out of the southern Great Plains and sort of a, you know, an increase in the sensible latent heat flux argument that accompanies that type of research. So great question.
Great, thank you, Victor. Next question is related to the STP change over time. Why does the slope of STP over time, why is it positive in the South versus negative in the Midwest? Is this a jet stream driven change?
Yeah, so very similar to the answer to Victor's question. This is, we believe it's primarily convective inhibition driven. So the decrease that you're seeing in places in Texas and Oklahoma are basically just saying that the atmosphere still has a lot of instability there. It's just that there's a lot of more warm air just above the surface that's providing a lid or a cap, or what we call a cap on the convection, not allowing it to form. And as that elevated mixed layer gets stronger and more widespread, once it gets east of the Mississippi River, those are your biggest severe weather days. If you look back through history at all big severe weather days in the southeastern United States, there's almost always presence of what we call the elevated mixed layer, which is really just a continental tropical, a hot and dry air mass that's just above the boundary layer moisture that's coming out of the Gulf of Mexico. So we think that's really the driving factor right now, but you know, this is still some preliminary work.
A question from South Carolina. We had an EF4 in Hampton, South Carolina, just across the river a year ago today. Is that an outlier or more likely in the future?
Absolutely not an outlier. In fact, this time of the year is the peak tornado climatology. In fact, probably this week and next week, when you look at annual cycle diagrams for many locations in the Mid-South, they do begin to peak here as we move into mid-April. And of course, that's not going to be the case this year. We're in sort of a sub-seasonal period, if you will, of offshore flow and cooler temperatures, which is really going to damper the tornado threat across a good chunk of the country, unless maybe you're confined to Florida or southern Texas over the next couple of weeks. But we do expect that to change, and so don't let your guard down. That is not an outlier. And you know, if you look at the trend analysis research, it certainly suggests that tornadoes, really, as at a broad sense, are increasing over a really large area of the southeastern United States.
Okay, excellent. We just have a couple more questions, so thank you for sticking with us. Do you have an explanation for the dip in tornadoes in the late 1980s?
Yes, drought. In fact, 1988, one of the more significant warm periods, warm anomalies, when you look back to the temperature records, that was a situation where the southern plains got very, very hot very early. We're talking 90s in late May and very, very early June, widespread upper 90s. And what happened there was a significant building of a high pressure system, a ridge in the central plains. That pushed the jet stream, or helped push the jet stream, this ring of fire pattern that many of you have probably heard of when we get into mid to late summer. It pushed that ring of fire and jet stream pattern well north into Canada. Canada actually had a record tornado season in 1988, but none of the tornadoes were occurring in the US. It was just a very, very hot and dry year. And that actually persisted into 88, the spring of 88 and into 89. But that does describe some of the decrease. It looked a lot to me almost like some of the summers of the 1930s. You think back to the Dust Bowl and this big positive feedback cycle that we had in the southern plains associated with drying out conditions and lack of precipitation.
Excellent, thank you. Victor, we have a number of participants from the Weather Service, weather forecast offices, and others on the call today. So this one is actually specifically related to the National Weather Service. Do you know of any coordinated efforts among the National Weather Service offices and media in the Southeast to begin defining a tornado season to make it part of the culture down here?
I am not aware of any widespread efforts. There are some individual WFOs that I have been in contact with, and my colleague Stephen Schrader at Villanova, who does a lot of the vulnerability research in addition to Walker Ashley at NIU. Those seem to be kind of one-off efforts. And of course, there's the Vortex Southeast Field Program campaign that's focused not only on the science, but also on the societal aspects of some of the very issues that I've touched on here today. As far as a widespread coordinated effort, I'm not aware of that. Of course, this is going to take something like the Southeastern Regional Climate Center and NOAA and the Weather Service and many emergency managers, right, and many different stakeholders to kind of step in and say, all right, we're not calling it Tornado Alley anymore. We need to educate people, especially people that are living in mobile homes, that there is no tornado season, and we need to get these people prepared at the tornado watch stage. We just cannot wait anymore till the tornado warning is issued. These folks don't have enough time. 13 minutes is not enough lead time if you're living in a mobile home. You have to start to take action earlier during the tornado watch stage, whether that's a community shelter, getting yourself to some sort of sturdy structure in town or wherever it is. Some people may have to travel, right, significant distances to get to safe shelter. So we ought to be just mitigating this threat by getting people to safety as soon as possible. And of course, there are a whole host of issues that come with that, including resources available. How do you get these people, especially people who can't leave their mobile home or don't want to leave their mobile home? I mean, there are just, this is multifaceted issue that's going to require many agencies and a lot of people with you know, a large, very significant, multifaceted educational campaign.
Great, and I'll just take one more question because of time. Has there been any specific studies on development expansion, so population shifts into tornado-prone regions over time? Is there any correlation between those two?
Absolutely. So we've done work not only looking at the impacts of climate change on tornadoes, running high resolution simulations into the future, but what we continue to see is that the worst case scenario is that climate change makes tornadoes more intense, more frequent, and the human built environment, the growing of our cities continues as well. Even if we have the same number of tornadoes in 2100 that we have this year, which is plausible, we're still going to see more tornado disasters in the future as our cities can grow larger. You can sort of think about it as a bullseye on a dartboard. As the bullseyes continue to grow larger, if you just close your eyes and continue throwing darts, and that bullseye just keeps getting larger, the probability of getting a bullseye, right, is growing significantly. And that's very true in many cities in the southeastern United States that continue expansion and growth into their suburban corridors, where these bullseyes are getting larger and larger and larger. So even if the frequency doesn't change at all in the future due to climate change, or even if the trends begin to reverse, right, all of a sudden there's no more increasing trend over the next 20 years and it just stays the same, we're going to continue to see tornado disasters, injuries, fatalities, simply due to this growth in the human-built environment.
Excellent. Victor, you win a gold star for answering questions really well and really quickly. So thank you. Sorry to put you on the spot there.
No problem. Thank you all so much.
Yeah, it was a pleasure having you here. I wish you all a wonderful day. Thank you for joining us today, and we hope to see you next month. Thank you again. Take care.